Hello and welcome back to another coding session with Mr. Jacob. Today I want to implement something I remembered while I was watching the Matrix movies again a couple of weeks ago. Matrix 1 is one of my favorite movies of all time, and so the original one. And I realized during watching that I never actually implemented this Matrix waterfall animation thingy. I've never actually implemented something like that. And I decided, why not do that and try to do it in a terminal so that we can get a little bit more familiar with cross-term again and learn more about it. And yeah, that's actually what I want to do today. I want to implement the Matrix Waterfall, Matrix Waterfall Green or something like that. If you don't know what I'm talking about, yeah, this essentially this kind of down scrolling matrix code that is in the movie the main display of the matrix in its encoded form, and we want to do something like that in the terminal. And I guess we won't find this special character. Oh, that's an interesting way of not allowing zooming. We won't actually be able to use those characters because those are special glyphs. But I guess we can create something out of nice looking Unicode to make it look nice. And let's see if we can actually create some sort of waterfall effect here. Okay, so I guess let's get started. Initialize a project here. How would we call it? Something with green rust, maybe. Why not? Why not green rust? I don't know. Maybe I will rename it later on, but let's see for now. So let me fire up my editor here. Okay, so let's get right to it. Open up the main file, hide the sidebar, and let's go. Yeah, I guess we need some dependencies from the front up. So let's add a cross term, which we definitely will need. And let's add anyhow, as we are always doing, anyhow error reporting anyways. So let's start by returning a result from our main, because I guess we will need that anyways. And we do use anyhow result. There we go. And yeah, it's again this damn thing with the brackets. I don't seem to be able to find out how to stop Visual Studio Code since one of the last updates to set brackets, automatically close brackets in absolutely irritating places. It always tries to do a nice and proper placement. Like, what I really wanted to do is something like, if I open it here, it should close it here. But I can show you, if I remove this result again, if I now type result, I open this one, and then I make an open parent. Okay, now it works, of course. It usually puts the parent something like down here, and I really don't like that. I just want it behind my cursor, and I don't seem to be able to configure that, because that always fucks up the code a little. So if you know how to do this, how to configure this, or have a link to something like that, please leave it in the comments, because it's really making me crazy here. Okay, so what would we actually want to do? I guess what we want to do is, what we need to do is some sort of basic struct called like matrix waterfall or something like that. And let's see, impl matrix waterfall. Yeah, I guess we will need to create that somehow. So maybe something like waterfall equals matrix waterfall new. What would we want to supply there? I guess this thing would need some sort of width, some sort of height, and maybe some sort of color, maybe some sort of base color or something like that. Yeah, I guess that would be That would be good. So where do we actually get those values before we are even implemented? Let me quickly implement just the fn new, which takes, or let's maybe first see where we get those information, because if I remember correctly, we were able to get me the documentation. We were able to get the size or something like that, terminal size, yeah, from the cross term. Great. So result, it's a U16. So let width height equal what was it? Terminal size. So let's retrieve that, and I guess we want to add a context here. So we need anyhow. Come on, we need anyhow. And did you see that, by the way? This time the brackets were okayish in the right place, but it doesn't always work like that. So I would love to disable that actually, because it makes more trouble for me than it helps me. So determine terminal size. Yeah, something like that. And we of course need to use cross term terminal, I guess. And yeah, then we need the base color. So base color, what would be a matrix green color? Is there something like that actually? Green hue matrix, something like, what's that? Matrix color palette. Okay, let's, okay, there is no, unfortunately, there is no, yeah, I hoped color hex, what? Okay. Yeah, that's something I can work with. Maybe, I have no idea. Let's maybe, this one, the quite aggressive one here, maybe? I have no idea. Yeah, let's kind of start with that. Or let's take the RGB values actually. Come on. And I guess we need some sort of color implementation, but I would assume we could steal that from our pixel loop project. So because we have done color implementation there, which is quite capable and even supports conversion from and to HSL and stuff like that. So let's copy all of that out here, I guess. And let's maybe create a new file here. New file, color rs. And let's just, oops, that's not what I had in mind. Oh, didn't I? Something went wrong when copying that stuff. So let's do it again. So now it should actually be in my clipboard buffer. There it is. Okay, so I guess we need to import that, of course, mod color. And then I guess we need to use color. Yeah. And I think then the base color could be from RGB, and that is where we want this one here. So let's do that. Yeah, now I guess we need to implement the matrix waterfall. So it will hold a width here now, which was a U16, I guess, and a height, which is a U16, and a base color, which is a color object. Yeah, I think so. And it has an FN, which is an FNU, and it takes a width, U16, a height, U16, and a base color, which is a color, and it returns a self, doesn't it? So self, this one should be easy. With height, base color. Okay. So, and then I guess what we would do is we have an kind of an endless loop here. And in this endless loop, we somewhat trigger the animation. So I guess what I would like to do here is something like waterfall render or something like that, maybe. And maybe this can fail, I don't know yet. We will see. So, but I guess we need something to advance it. So something like waterfall step maybe as well. Yeah, and then I guess we need some sort of STD thread sleep duration from millis. Don't have no idea. 150 milliseconds. We will see in a second, I guess, or yeah, in some milliseconds. Haha. How well we have chosen this value. So yeah, let's see. So let's kind of implement the FN, what did I call it, render? Does it need, I guess we should give it some sort of output, shouldn't we? So it needs something to actually render to. So maybe what we want to do here is something like, we usually want to render to std out, don't we? Yeah. So let's do something like stdio, std out, I guess. And I guess this one needs to be mutable. So let's get this stream, this std out implements right, doesn't it? Can I see that somewhere? Wait. Rust std out. Std out, does it implement buff? Right, wait, traits, right. Okay, so, no, wait. That was not where I wanted to go. So std out, do we now have std out? Yeah, I really want to give me that. So does this one implement right? Trait implementations right. Okay, so it implements right. Okay, that makes things a little bit easier for us, I guess. So I guess then what we are doing here is we are just putting a mutable pointer to std out in here, I guess. Do we need this for the step function as well? Don't know yet, we'll see. And then render could actually do something like we have something of type right here. And yeah, we need to import it, of course. And then we have the self, most likely something like a mutable, maybe not, we will see. A self here. And we get a mutable reference to a W, which we call something like out, maybe. And we return a result, because I guess writing can fail actually. Okay, so how would we do that? I guess we would kind of need those columns which we are animating down. Yeah, so maybe we should create something like those columns. A column, do we call it column? Yeah, let's call it column for now. So I guess a column has a height, which is a U16, and it would have a base color as well, I guess. So this is a color. And we will see what it needs in the end as well. So impl, not color, column, come on. And I guess it needs something like render then as well, which returns a result. So, and how would a column actually be rendered? A column would need, what kind of glyphs or characters, or how do we call them, are in there? So let's see, I guess this matrix waterfall has then a vec of column objects, a vec of column structs. Yeah, I guess that makes kind of sense. And let's for now maybe just initialize those empty and make a to-do here. To-do fill properly. And I guess a column has then characters or glyphs. I guess I like glyphs, which is a vector of glyph. Yeah, and we don't have glyph yet, so struct glyph. And a glyph would have something like a character, I guess, which is a char. There is, oops, what did I do there? There is a type like char, or is there? And maybe a color. So in this one will have a, yeah, makes sense because it needs to have a color somewhere. Yeah, okay. So, yeah. Okay, so now when we render a column, we can actually iterate through our glyphs and then but then we would be rendering the column. And in order to render in a column in the terminal, we would actually need to reposition the cursor for every character that we render. Maybe it would be more intelligent to render line-wise. Yeah, I guess we could actually do that. So let's see. How would we do that? So first of all, we would kind of, for y in self.hide, so 0 to self.hide. So I guess we can iterate here. And yeah, in the end, we will return okay. So shut up about that. Okay, so now we render the lines, and then we would do something like for column in self columns, and I guess we need to we iterate them as a reference. We do something like column.render. Yeah, but then no, we actually could give them the y where they are, and we definitely need to give them the reference to out as well. So, and I guess this one will return a result as well. So something like this. Yeah, that makes sense. And then this one would take actually the out, which is a mutable pointer to right implementation, so right, and the y, which would be a U16. Yeah, okay, this makes sense. And then in the end, if everything went fine, it can return okay, so it doesn't scream at us with not giving the result. Okay, so and now for the column y, we are actually doing something like we are going to, and we need, of course, we need a self here. We are taking from self glyphs the yth entry, because I guess we will in the end have a glyph for every row. Yeah, that makes sense. And we call on that one render to out. Yeah. I guess that could actually work. Yeah, and this will not work, of course, because indices are a usize. And now, yeah, this will not work because a glyph does not have render. So let's see, struct, no, impl, glyph, fn render, we called it, and it takes some sort of write implementation. So it takes an out, which first of all it takes a self, and then it takes an out, which wait a second, is a mutable w, and it returns a result. And let's do that first so that it doesn't scream at us. And then here we are actually rendering the glyph. So what we would do here is something like we need to check how all these things with the color and so work. But for now, we maybe just could do out, write, and it takes a U8 slice actually. Can we actually convert a character? So if I do character dot, is there something like 2 bytes or as by? Let's see what a char actually can do for us. So primitive type char. Actually would love to have something like, do I actually need to make a string out of it to then char try from, oh yeah, the primitive type char. So char is a Unicode character. Yeah, that is actually nice. But how can I char max replacement decode from come on, from digit? No, I don't want. Can I do something like 2 bytes, or is there something with bytes? I just want to can occur from bytes to turns the number of bytes this char would need if encoded in UTF-8. Okay, I guess I really need to encode UTF-8. So encodes this character as UTF-8 into the provided byte buffer and then returns the subslice of the buffer that contains the encoded character. That is into the provided byte buffer. Wait, do I really need to create such a byte buffer? I don't want to. Isn't there something like, I guess what we can do is to string and then as bytes? Okay, so let's maybe do that. Okay, so now what we actually would need is, let's for now comment that out, or maybe quickly implement that because we need some sort of stepping anyways. So step most likely takes a mutable self. And does it return something? Maybe a result? I don't know. We will see. And what does that actually do? I guess it iterates all columns and steps them. Does that make sense? Because they need to, yeah. So for self column columns. No, for column in self columns like this. We want to do something like column.step, I guess. And then I would need to implement that in column as well. So yeah, so let's see, where am I? There. So fn step and that actually would need to kind of move the glyphs around, but I don't want to actually shift them around. So I should do something like maybe store an index where we start. Yeah, that actually would make sense, so that we can actually kind of... Because we will need to constantly override them. Yeah. So, yeah, let's do something like active index or something like that. And the rendering is fine actually, but what we want to do now is every time we step, we do something like self.glyphs. Self.act. What? Acro? Where does that come from? Active index? Oh, yeah, we definitely need a mute self here. Equals something like maybe glyph new or something like that, which we haven't implemented yet. And I guess we gave it a character, so maybe we do something simple like A here for now, and we gave it the base color, which we can take from ourselves because we know it. And then we do something like self active index plus equals 1, and if self dot active index is bigger or equal self dot height, we set the self active index to 0 again. And we don't have a height. A column doesn't know its height. Yeah, it does. So it's the wrong type as usize, because the height is u16. So now we need a glyph new. So fn new. I hope that we can soonish render something to the screen, because I'm not 100% sure that what I'm currently implementing here will work. It should. It is not that complicated, but let's see. We first of all need kind of the framework to draw anything, actually. So maybe I should have started with that. Yeah, maybe. Maybe went ahead to and deep dived into it. So what did we put in there? We put in there the character and the base color. So character is a character, and we have a color which is a color. And we are returning a self then. So we are returning a self by character and color. Yeah. So and I guess we somehow need to initialize columns so that we actually have something to render, because we are assuming here that we have something to render. So let's see, fn new, and the column takes a height. Perfect. Height, u16, and base color, I guess. So I guess there isn't much more to it. So what we then are going to do is we are initializing with height and base color, and we need to somehow create certain glyphs, and we have an active index that is 0. Okay, and glyphs is something like let glyphs I guess we need some sort of empty glyph or something like that. Maybe we can fn empty returns a self, and that would be self character would be something like space, I guess. And the color, what would be the color? The color is actually not really relevant here. Something like black or white. Actually, let's just create a black color then, I guess. Because the character is empty, so you will never see that color. Okay, so now we should be able to do something like vec glyphs empty semicolon height, most likely as usize. Okay, what's the problem here? Glyph clone. Oh yeah, it needs to. Oh, I see. But I guess there shouldn't be a real problem to derive clone for this one. Why not? Okay, so now we have glyphs, and maybe then we can actually inline that. Yeah, I guess that's a little bit nicer. Okay, and now we have still problems here. Cannot borrow column as mutable as it's behind a shared ref. Oh, can I do, by the way, something like that? I can actually do something like that. Maybe. So what's the problem here? Cannot mutate immutable variable waterfall. That's not a problem. We can make you mutable easily. Result that must be used. I see. So let's use this result. And yeah, I guess this one will technically never be reached now. So let's remove it and let's see if there is some result that must be used. Yeah, I guess then let's do that. Unused result. Yeah. So context write glyph to output, because at this point we don't really even need know that it is the std out, and maybe something different. So let's see, and there are no more errors. So maybe now let's see what happens if I actually do a run. It should actually print some characters onto the screen. Let's see. Okay, and it does absolutely nothing. Okay. Oh, we are actually never flashing. Is that maybe a problem? Do we need to... maybe, let's see. Maybe we want to do something like, after we have written all of those columns, maybe we want to do something like flush. So out.flush. And can that actually... Yeah, I guess it can. So context flush output. So let's see. Was that the problem? No, it wasn't. So somewhere along this construct, we are not actually... Oh, we are never adding any columns. I even put a to-do there. Yeah, so I guess we need to do something kind of equal to the glyphs and have the possibility to create an empty... So something like an empty column, I guess. So fn empty, but the column definitely needs some sort of height. Yeah. Do we actually... I guess we can do that with new. We don't need empty there. So what we actually want here is something like, we want a column new with the given height and the base color. And we want that actually width as usize times, don't we? And then we have the same problem. The column can't be cloned. But actually we should be able to... As glyphs can be cloned, we should actually be able to maybe derive clone here as well. So I guess that should work. Yeah. So now let's see. Okay. Yeah. It seems to print correctly. We are not clearing the screen yet and stuff like that, but we are actually printing ace. That's a really good start. So now let's see. We need to do some more... Now we need to do some more magic with with cross term. So let's see, cross term. There was something like move, move to, move up, move to, cursor, move to. So we could actually, can we actually do something like, let's see. So the waterfall render function, before it iterates the columns, can I do something like std out? No, it's called just out here. Here. And then I need cross term, I guess. So cross term cursor. And I want to do something like cursor move to, can I simply move it to 0, 0? No method named Q on mutable. Okay, but isn't that provided by cross term? Traits. Yeah. Q. No, wait, what? Use one or more commands for further execution, but that's actually okay. Do we need to do it with this Q macro then? Yeah, I guess we can. I guess it's because we don't have an std out now, but we have a writer actually. So use cross term Q. So where there. So I guess then we can do Q. I can never write Q. We can now do something like that. Okay, and that actually can fail, I guess. Yeah, okay. So what we now do is we are moving the cursor to 0, 0. Yeah, okay, I see. So, and then we are writing it and then we are flushing it. So essentially, this should fix our print everything over and over again problem. Let's see. Okay, so this looks a lot better, I guess. Yeah, and as you can see, it already moves back again every time. So let's see what happens when we are at the end, because essentially then it should start again. Okay, but you have seen the cursor move around. Is there some way of something like cursor? What is here actually? Hide. Okay, that's actually quite nice. Can we actually do something like Q out cursor hide? And I guess this can fail as well. And then once we are, or just before flushing, we do cursor show again in case we are aborting that. Actually, that's kind of nice. Okay, now it's flashing down here, but it isn't moving around there anymore. Okay, so yeah, I guess now it's time to implement some sort of scrolling behavior. But I guess for that we need randomness. So let's see how this randomness thing is called. Randbook Rust, that I always forget, which we used in the our RNGs, which we used in the pixel loop as well. So we used this one, and this one was actually a quite nicely and fast usable thingy, and it came from rand something. Okay, so cargo add rand this one, and we need the rand crate. Okay, so I guess then we can do something like use rand exactly, and it was called Zoro Shiro. No, it was called something like 256 plus. No, it wasn't. Okay. There. Okay. So Shiro something. um, yeah. Okay. So let's get that, and then let's initialize it here. I guess, yeah, I guess we can simply do that. So this was rand equals seed from U64. Okay, we need some sort of U64, so let's call that seed, and let's simply take maybe the duration. Let's see, seed. Can we do something like std? Is it time? No. System. Where does system time actually live? It's std time. Okay, std time now. So and then duration since system time. There is something like Unix epoch. Yeah, exactly. That should give us the seconds in, and then we do as millis. Can we? Can't we actually get something like we should now have a, oh yeah, this can, okay, expect time to have passed since Unix epoch. So I guess we can assume that this is the result returned there is something really, and now we should be able to do something like as micros. I don't actually have, no, I want something that returns me a U64. So let's go for seconds then, I guess. Or maybe we do something like as micros, and then we just cut it off. This should actually make it a little bit more random then. Okay, and no function associated seed from, wait, didn't it just, okay, that's, didn't it just complete that for me? Okay, it's even an example. Oh, I guess I need to include something for that then. Is that right? Yeah, it seems to be, because now there is no error anymore. Okay, so now we have actually a random thingy here, but then I guess we need that for stepping, don't we? So I guess we need to put a mutable rand in here, and then this one will need to take something like that. So I guess we will need use rand, what is it called? RNG core, I guess it was called. Yeah, okay. So wait, waterfall step now takes a rand, which is a mutable reference to our RNG core. So this is actually now something that can do that, and this cannot mute. Okay, yeah, I need to make that mutable. Okay, perfect. And then we need to, I guess, pass that to the column step function. So where is our column step function here? So this one needs to take an a rand, which is a mutable reference to an R, and R is RNG core. And yeah, okay, so what we now want to do is, let me see. I guess we want this waterfall effect so that they should start in different with a time delay, a random time delay. So I guess what we want to do is something like if rand.gen f32 or something like that is less than or equal to or just less than 0.1 or something like that. Wait, if self-active index, so only if active index is 0. And randgen is bigger than 0.1, then we simply want to return. So we are simply waiting, and I have no idea if this value is a good one or if we need to change it. What's the problem? No method gen. Oh, because gen is not on RNG core. It's on. Is it simply called RNG? Can I do something like that here? Can I? RNG should actually be automatically, or whatever this one is called. Maybe I need to look it up. It's automatically implemented for all RNG core thingies, but that seems to work. Okay, so now actually it should maybe look a little bit more waterfall-y. Let's see. Okay. This actually, and I guess the value isn't that bad. Actually, it looks kind of waterfall-y. So yeah, so that's already quite nice. So let's see. Now we need some more color or some more characters. I guess I want more characters first because then I can see that it overrides them correctly. So actually, every time we create a new glyph, we somewhat need to take a random glyph. So okay, maybe we do something like new random here, and we give the glyph the chance to create a random variation of itself. So new random. Oh, but then it needs a random number generator. Yeah, but we can do that actually. So this is then RNG. Come on, and it takes I guess the RNG then. So a mutable reference to R, and it takes a color, doesn't it? So, and it returns self. And then it simply does self. Character, yeah, we need to implement that, and it takes the color. Okay, so how would we actually, first of all, we need to pass the random thingy then here. So, but where do we actually take those characters from? Are there already some available, or do we need to matrix Unicode Waterfall? Are there any color thingies here? Is there a list of symbols? Yeah. So, oh, okay. Nice. So let's see. I guess we can kind of take all of them. So what we need to do is some sort of constant, or maybe just put them in here for now, just for good measure. So characters equal, and now we need to clean up a little. So what we want is this one here, and we want those, and we want those, I guess. And yeah, this can go, and no. I didn't want to delete some, so let's put that there. So the numbers are kind of in there, I guess. So upside down. Okay, I see. So it's not. They are not perfect. In there, the Z, it seems. Then punctuation. Yeah, okay, I can do that. We need to escape this one. We have those. something like that, and something like that, and I guess that was it. So let's take those, and then let's do something like character would be rand gen range from 0 to characters.len. No, characters dot. Actually, is len the byte length, or is it returns the length? The length is in bytes, not chars or graphemes. In other words, it might not work. Yeah, that's actually a problem because we need those as chars. Yes, so I guess we need something like chars.len. I guess chars is an iterator. Ah, damn. Yeah. Yeah, that's actually not... okay, so for now, this kind of always creates the iterator and then counts the elements in it, and that's definitely not very performant. But it doesn't even seem to work. Gen range, expected char, found user. Yeah, we need now characters, and we need to take this generated one there. And str cannot be indexed by users. Okay. No, I need chars, and that's another problem. And then I would need nths. Yeah, that's definitely not really good what I'm doing here currently. But I guess it might work. What's the problem now? So, actually, yeah, okay. But we are sure that we can actually unwrap that because we checked before that we are within the range. So let's put a very big to-do here. To-do, don't use chars iterator to count chars here every time. We need to somewhere initialize this statically and then use it. So but this should now maybe generate random character. Okay, it kind of works. What's happening there? Can it be that yes, there are characters in there which are bigger than the normal column size? Okay, so now I guess this one should work. Okay, this already looks kind of nice, I guess. So, but I have the feeling I kind of doubled the... Did I not? I have no idea. Okay, but it looks, this looks already kind of nice. And maybe we can do it, make it a little bit faster. And see even if the console can do that actually, but it should, yeah. Okay, this actually looks nice. So now let's do something about coloring, I guess. Okay, so we need to then take a look where we are drawing the glyphs first of all. So we somehow need to, where is it? Render. So how do we actually do that with cross-term? I have no idea. So is there something like color? Style color. Okay, so yeah, that's the default color thingies. Oh, okay, you can use ANSI color value, color RGB. Okay, oh yeah, that's the 256 color. Yeah, okay. The ANSI color would be the 256 ANSI colors. So we could either map to those, or we can simply use RGB, because all modern terminals I know can do RGB. At least the Linux and macOS ones. I don't know about the Windows ones. So, okay. So is there style color? Yeah, but this is, how do I actually style. Oh, okay. Set foreground color, set background color, set colors. Okay. So can I do... Interesting. So what does this one actually take? It takes colors. So, and colors is a... Interesting. Okay, so so what if we do something like... Wait, can I then just print this, or how does it print? Okay, prints the given and print what? Print styled content. Styled content? What's styled content? Okay. Okay, interesting. Do we need that, or can we do that? Okay, let's try something like what was that? It was Q on out. We want to do something like, we need to import that. Use, and I guess we can somewhat collapse this, those thingies here. So we have the Q, we have the terminal, and now we have style, and then we can remove those. And yeah, we are not using style yet. Where were we? They're out. And I want something like style set background color, first of all. And I want something like style color, RGB, yeah. And I want something like simply 0, 0, 0 there. Yeah, and this can of course fail, I see. So, and now I want more or less the same thing, but with foreground color. And then this would be self-color.r, which doesn't seem to work for some reason. Self-color.rg and self-color.b. Why don't you like that? Field R of color is private, really? Yeah, okay, I guess we can just... Come on, we can just change that, can't we? So, okay, now this should print the color then, and it should set the background color. But maybe it's not that wise to set the background color for each glyph. Yeah, we will see. We can optimize that maybe later on. And then we need to do something like out.write, no, Q out. And then there was something like style print. And then can we do can we do something like that? Okay, that does not work. Doesn't implement display. The trait display is not implemented for... Okay. Yeah, then... Okay. Okay. I guess we should set some sort of color for now. I guess we are setting black or something like that. No, we set the matrix color. So let's see. Oh, okay. That's already starting to look a little bit more matrixy. Okay. Now can I actually move that maybe before rendering the frame, something like here somewhere? So and then maybe in the end I should do something like, is there something like style, something like reset color? I know there is an ANSI code for that, so I guess I guess there will be some sort of color reset. Okay, so resets the terminal color. So I can actually, yeah, but wait, that's a color. I don't want a color, isn't there? Reset color, command that yeah, that's something that I looked for. So reset color. Okay, so this should actually not change anything. Yeah, okay, that's nice. And now I guess we need to implement the color fading. Yeah. So where would we actually do that? I guess we would do that on a column level because we needed to do it every step. So the steps would then go ahead and wait, no, actually not. Yeah, we, So actually this is waiting here. Then what we need to do is we need to create a new one at the active index, but we need to iterate all of them and we need to fade down their color. Yeah. So what we actually need to do here is, yeah, I guess we want to do that before. So what we want to do here actually is something like for glyph in self.glyphs, and we want immutable reference to those. And we simply say then glyph.fade, fade color, something like that. Yeah, I guess we want to do that. And then we want to implement something like fade color, fn fade color mutable self. And what this one needs to do is then it needs to take self color. And I guess it wants it as HSL. So let's do let HSL equal self color as HSL. So now we have an HSL representation of that. And then we need something like self color equals HSL color new HSL. The hue stays the same. The saturation, do we want to change the saturation actually? I guess, yeah, I guess so. So, so HSLS times, I don't know, 0.8, HSLL times 0.8. And then I guess we need to do into here, and we need to import HSL color. And this may already be it. Let's see. Okay, it's kind of too quickly fading out, but it's fading out already. And it's then, oh, it's staying there until it's starting to iterate again. Oh yeah, that's actually a problem. So I guess we want to fade the color before we even do that check. So I guess the columns should fade every time. So let's see. Yeah, now they are properly fading out. Okay, this actually looks quite awesome already. So let's see. Let's do something like maybe we are just doing 0.9 here to make them have a bigger trail. Yeah, this looks a lot better. Maybe even longer. So maybe something like 9.3 or something like that. Yeah, that's a little bit too much. So this was already good. So yeah, okay. So what could we actually do there? to make it even better, maybe we don't want to fade them out completely. Like, let US equals hsl.s times 0.9 if if I guess what we could do is something like let new color. So, and then if new color dot s is less than 0.2 or new color dot l is less than 0.2, then we will simply have self dot color equals hsl color new hsl h 0.2 0.2 maybe. Wait, why is this? Okay, because I'm missing an into here. Yeah, and otherwise self.color is simply new color into. Come on. Yeah, so now it should stay some sort of darkish. No, it's still completely. Yeah, it's. Or is it? Yeah, it's going completely dark. Why is it completely going dark? So, is that too dark maybe? Maybe we need something, but I can't really. No, there is something wrong there. So, I'm creating this new color here, and what values do we actually have for HSL? Oh, we are in steps 0 to 100. Okay, then this makes a lot more sense. So if this is less than, let's say, 20 or something like that. So if it's less than 20%, then I want 20. I thought it was in the space 0 to 1. So, but I guess it still needs to be a float, and this one then needs to be a float as well. So let's see. Yeah, this actually, yeah, but it's a little bit too bright still. So let's do something like 10 maybe. 10. And then let's do 10, 10, and let's see. Yeah, that's actually nice. So you have this really slight shadow in the background. Yeah, I like that. I guess we are done. We can maybe make it a little bit faster still. Maybe something like 75. Yeah, this actually looks really awesome. I like it. Never implemented something like that before, and now we have done it with Unicode characters in terminal. I didn't think actually that this would perform quite this well. I mean, the terminal is quite small. Maybe let's try it with my normal terminal size, and let's do it. But yeah, it performs admirably. You know the word, admirably. Admirably? It actually performs quite well. I wouldn't have thought that it would do. So that actually looks really, really nice. I like it. I would have thought that we need to implement some sort of detecting which characters changed and which didn't, and then need to update only those. But yeah, I guess we can leave it at that. Maybe we could try if we change the color. How would it look with a different color? Like something like let base color. Just for fun, maybe we could parse the command line then and take a different color there. Something like 255 260 or something like that. That should be some sort of orange, I guess. Oh, that actually looks quite nice as well. A little bit like such an old Ember screen, not a fluorescent green one, but those Ember thingies. Yeah, and then I changed the zoom level. And that is something like, maybe we can detect if the size of the terminal changes and reinitialize that. That really looks nice. I like it. I like it very much. Yeah, but I guess we will stay with the original Matrix C1. So, yeah. That's actually really nice. And yeah, I had a lot of fun doing that. Yeah, I hope you had fun as well. And I finally implemented a Matrix Waterfall animation thingy in the terminal. So yeah, I hope you had fun as well. And I hope to see you in the next one. Bye.